Hello everyone. Uh, Today I'm going to talk about 5.5 applications of inner product spaces. And my name is Eileen. First of all, I'm taking you through the topics that I'm going to cover today. First is a cross product in R cubed, and then is the least squares approximation, and then is a Fourier approximation. Now is a cross product of two vectors. The cross product of two vectors, u and v in 3 dimensions, is another vector that is perpendicular to both. It is computed using the determinant formula shown here. And it's important to remember that the j component comes with a negative sign. This product only exists in 3 dimensions. The next is the example for the cross product. Here is a concrete example. Given vectors u equals I minus 2j plus k and v equals 3i plus j minus 2k. We compute their cross product to get 3i plus 5j plus 7k as seen up here. Notice that swapping the order of the vectors reverses the direction of the result. Next is the properties of the cross product. Some key algebraic properties include anti-symmetry, distributivity over addition, and behavior under scalar multiplication. Also, the cross product of any vectors with itself is always 0. Next is the applications of the cross product. The cross product is used in physics for torque calculations, as seen up here. It also gives us the area of the parallelogram formed by two vectors, which is the magnitude u times v, also shown up here. And next is the least squares approximation. Moving on to the function approximation. The goal of least squares is to approximate a function fx with a simpler function gx, minimizing the integral of the squared error. For example, when approximating fx equals e to the power of x on 0 to 1 with a linear function, we get gx equals 0.873 plus 1.690x. And next is the least squares quadratic example. If we follow a quadratic form, the approximation improves. The best fit is then gx approximately equals 1.013 plus 0.851x plus 0.839x squared. This shows that increasing the complexity of gx gets a closer fit to fx. Next is the Fourier approximation. Finally, Fourier approximation is a special type of least squares that uses trigonometric functions to approximate periodic functions. For instance, approximating fx equals x on 0 to 2 pi using sine functions gives us a Fourier series like pi minus 2 sine x minus sine 2x minus 2 over 3 sine 3x. And last of all is the summary. To recap, the cross product helps us work with 3D geometry and physics. The least squares approximation gets the best fit functions in a chosen subspace, and Fourier approximations extend this idea using sine and cosine functions to periodic behavior. Together, these applications show how inner product spaces provide both geometric and analytical power in mathematics. And thank you for listening.